problem I'm going to talk about. pH calculations, from your science classes, actually have to do with a log. pH is found by doing a negative log of the hydronium ion concentration, or H3O+. So we will use this formula to calculate some pH values. So pH, you're looking for like the acidity or alkalinity of a solution. So if I asked you to find the pH of a solution where the hydronium ion concentration is 2.5 times 10 to the negative 4. You are not going to have to memorize these formulas. I could very easily put a pH question on the test, but I will give you the formula for how it's found. So the formula that I just said is pH is negative log of that. So if I put this on the test, I would give you that formula. So we just do a negative log, and H3O+ is equal to 2.5 times 10 to the negative 4. So then we're just going to put that in our calculator. Negative log 2.5 times 10 to the negative 4. And usually pH we round to 1 decimal place. So we would say 3.6 for the pH of that solution. Question B, I'm asking for the H3O+. I'm telling you pH is 7.1. So if we plug that in, 7.1 equals negative log H3O+. So if I'm trying to get the log by itself, what would you do with that negative? Okay, so then we could change this to exponential form. What's the base of this log?
10.
So it'll be 10 to the negative 7.1 equals H3O+. If you type 10 to the negative 7.1 power in your calculator, you get this decimal. I don't really remember, this assignment is Math Excel. I'm trying to remember how many decimals it told you to keep on these. So typically, just like in the previous problem, when I gave you the H3O+, it was written in scientific notation. So we are going to put our final answers in scientific notation here. So that times 10 to the... Okay, so let's just do 1 decimal. So we see 7.9, and then at the end it has E negative 8. What that means is 7.9 times 10 to the negative 8. And so I just pulled up the Math Excel. That's how it has you write the answers. There are different ways, but we'll just be consistent and try to do that. Are there any questions with that one? So the second type of problem that we are going to look at involves exponential growth and decay. So this is something that comes up like in talking about populations. If you're looking at how a population changes over time, the bigger the population gets, then typically the faster it is increasing, so that makes it an exponential type. So exponential, we know, is just when our variable is in the exponent. So it will look something like A sub 0, which is just our beginning amount, e to the negative kt power. Actually, let's just do kt. It actually works out the same either way, it just turns out to what your value k is, but we can keep life a little bit easier if we just keep it as a positive. So basically, if your k is greater than 0, that would be growth. As long as that number is positive, your amount would be increasing, and when it's negative, that would be decreasing, or we call that decay. So this is just a type of exponential, so we could solve some of these. And I've got several examples of this. So the first example, if 800 grams of a radioactive substance are present initially, and 2.5 years later only 400 grams remain, how much of the substance will be present after 4 years? So what we need is the equation.
Is that a T or a plus sign you're putting in there?
T, like tide. A sub 0 is the beginning amount, which is my 800 grams. That's what we started with. So I already know this equation is going to be 800 e to the kt power. T is the variable. Here we need to find k. That's our constant. And so what we'll do is use the numbers they gave us to find that. So 2.5 years later, only 400 grams remains. So the A of t, the amount, was my 400. Well, 800 e, we don't know k yet, but my time in this scenario, 2.5. All right. So if you wanted to solve, what would you do with that 800?
Divide it.
Divide it. 400 divided by 800 is 1/2. K times 2.5 is just 2.5k. Then what would we have to do?
ln.
Mm-hmm. The exponent comes down. What happens when you have a natural log of e? Mm-hmm. So then to get k by itself, we just divide by the 2.5. So we just need to do the natural log of 1/2 divided by 2.5. So then I have my k value. So my function, the actual equation here, is 800 e to the negative 0.2773 t. Now I know the function, so we can answer the question. How much will be present after 4 years? So what are we going to do? Plug in a 4. So you just grab your calculator and replace your t with a 4. So we had 263.86 grams. So basically, as time goes on, this is decaying. We have less of it over time. So 4 years later, we're down to only 263 grams. Questions about that? Yes, ma'am.
I think I typed it wrong.
Okay.
Hey Reese, you grabbed your pencil. Hey Reese, this is going to do
another one along those lines. Those are a bit more challenging. So if 600 grams are present initially, and 3 years later only 300 grams remain, how much will be present after 6 years? So we're still talking about exponential growth or decay, which on a test I would give you any of these formulas. You're just using them for the assignment. So what would we do first? What's my A sub 0?
600.
That's the starting amount. So we have to find K. How would we do that?
What's that the,
We know that
RU 3 times, okay.
we can plug in the stuff. So 300 grams would be my ending amount. So 300 equals 600 e to the k times time was 3. So divide by 600. Add our natural log. We know a natural log and an e cancel. So then to get k by itself, we just divide by 3. So we're getting a negative value for this because our amount is decreasing over time. So we should get negative 0.2310. Did everybody get that part to work out? So now I asked you how much would be present after 6 years. So what do we do?
Plug in a 6.
And we get 150.0. We'll just round it to 150 grams after 6 years. We have really two last types. We've done interest before, so this part isn't new. We know the interest formulas. I give you both options. If I'm asking about continuous compounding, that was the A equals PE to the RT formula. So if I said, how long will it take for the money in an account that is compounded continuously at 5.75%? What is that? To double. Did I actually tell you how much you had to start with? So let's just make up a number. P, that's what we started with. How much do you want it to be?
2.
2. Then my ending amount, if I want that to double, what would I end with? 4. So if we plug this in, 4 equals 2e to the 0.0575 t. So then what do we do? Divide by 2. And then add the natural log. We know a natural log and an e drop. So to get t by itself, we just divide. So natural 2 divided by 0.575. Time is measured in years, so it takes just over 12 years for this to happen. Another one like that? How is this one different?
Because it's quarterly.
Quarterly.
So we have to use the other interest formula? Okay, so what is the 1,000?
Present.
2%, so the rate is 0.02. Compounded quarterly, so N would be
4.
4. What's the 2,700? A. We plug in. Alright, so then we have to divide by the 1,000. 1 plus 0.02 over 4. We can simplify that a little bit. Then what would we do?
Log.
You can add either one, but it's not, we usually just do the regular log because we don't have an E. So log of 2.7 equals 4t log of 1.005. So then to get t by itself, we have to divide by the 4 and the log 1.005. And you'll need an extra set of parentheses around that denominator. So we get 49.787 meters for the ton. Last thing I want to talk about. There is a formula called the change of base formula that allows you to take any log and put it into what we prefer would be base 10 or the natural log, so we can use the calculator. Now I am aware there is a way in your calculators you can put in like log base 2 of 8. You know, we've talked about that. You can get to it in the menu of functions. On these, on the Math Excel, and when I put it on the test, I will require you to write this formula so that I know you're using it. So if you just give me the final answer, you will not get credit. So in order to change the base, you can go to whatever base you want by doing log of the argument divided by log of the current base. So for example, if I asked you to use this formula to approximate log base 5 of 7, then we would turn this into log, we'd go base 10, since that's the button on our calculator, of the argument, so log of the big number divided by log of the small number. So log 7 divided by log 5. So you would have to write that step, and then you get 1.20906, so 1. So what would we do for B?
Same thing.
So it'd be log of, and so that gives us maybe 3.3219. Okay, do I need to do, I put another set of examples with these, we need to do them.